that day we have discussed about this, right? Oh my God, just
Yes, ma'am.
yes, about the separating the components of a mixture, right? So we have learned about evaporation.
Yes, ma'am.
Yes, yeah. So evaporation is done. Separating funnel also done.
Yes, ma'am.
You know, right? Ki what is the the example of separating funnel, that kerosene, oil, and water, right?
Yes, ma'am.
Okay. So let me just quickly revise. What is evaporation? Anybody? Arham, what is evaporation?
Evaporation, it's like the process when a substance from a liquid state changes into a gaseous state.
Yes.
Ma'am, at a temperature below its boiling state. It
Yes.
has to be, it's a, uh,
Ma'am,
uh,
like the liquid doesn't have to be heated separately.
yeah,
It can be done like even with a little amount of heat. There's a
Yes.
specific amount.
it doesn't have to be 100 degrees Celsius.
Okay. Now next, what is the this separation by using the separating funnel?
Ma'am,
Anybody explain? Huh? Yes, Razi.
now we have to explain using the separation of a like a funnel, right?
Yes, funnel. Yeah, this part. Arham. Here, what we have to do, we have to separate two immiscible liquids, right? And what is immiscible liquids?
He can't mix.
Ma'am, liquids that don't mix with each other.
Yes. So the example, we can take oil and
Ma'am,
water.
oil and water and honey.
Yes, honey and
Alcohol and water.
yes, because density of oil is lower than that of water, right?
Honey and water.
Honey and water.
Alcohol and
Honey is more dense than water.
yes,
Yeah, yeah. Honey is what?
more dense.
More
Yes,
dense.
more dense than water. Yes, and we have discussed about this also, no? Sublimation. Here, liquid phase is not included, only directly from solid to liquid gas. Okay, and about the fractional distillation, we have discussed? No. So first, here we will learn about what is centrifugation. Okay,
Centrifuge.
just here.
I mean,
Where's
one
that?
of the questions, and one of the questions in the assignment was the answer was centrifugation. I couldn't find it, and I didn't know the answer, so I looked in my book, and in the book it was centrifugation.
Okay, yeah, I'll explain. That day I have discussed about the crystallization also, right? That what
ma'am.
is the difference between the
Yes, ma'am. You
evaporation and
discussed it.
Yes, ma'am. Yes, ma'am.
yeah. Okay, so today let's start with centrifugation only. No. First, let me discuss about this. Okay, first tell me, filtration is done, magnetic separation also done,
Yes, ma'am.
sublimation is done, separating funnel done, evaporation done.
Yes, ma'am.
Okay, and distillation is not done, right? Okay, so first let me discuss it. Why am I? Now, this is distillation. This is what? This is distillation. Just a minute, huh? Let me just rotate my screen. It will be clearly visible. Now, so any idea? See, distillation is what? Distillation is a process of separating two or more miscible liquids. Okay, two or more process.
Mixable liquids.
Miscible liquids are what? Which can mix in liquid, right? And immiscible are what? Immiscible are like which cannot mix, like kerosene and oil. Sorry, like kerosene and water. So process of separating two or more.
Ma'am, like orange juice and carbonated water.
What?
Ma'am, like orange juice and carbonated water.
Orange juice and carbonated water are miscible liquids?
Yes, ma'am.
Yes. So they are the example of this. Miscible are what? Which can mix together. So here, which can mix together. So here, let's say this is my beaker, and in my beaker there is a acetone and water. Okay, acetone and water.
Ma'am,
Water.
petrol and diesel, ma'am. Petrol and diesel.
Okay, petrol and diesel, but first let's take this example, acetone and water. And what is the boiling point of water?
100 degrees Celsius.
100 degrees Celsius. And acetone is of 56 degree. Okay, boiling point. Okay, so here what happened in our beaker, the acetone, the mixture of acetone and water is there because they are the miscible liquids. They are mixed together in one beaker. So how to separate both acetone and water? Any idea?
Ma'am, like to boil the water.
What?
So, ma'am, you could like boil the you could boil the thing, the
Yes.
and then just the water will be left.
We will heat it. Okay. Any more, Razi? Any idea about this? That how we will separate both miscible liquids?
Ma'am, the acetone's boiling point is less than water. I think that then when we will heat it, the acetone will vaporize
Yes. Very
earlier
good.
than water.
And then what will happen after vaporization?
Only
Ma'am,
water.
it will reach in the other beaker.
Yes, it will reach in the other beaker because the boiling point of
Oh, so
acetone
ma'am,
is
what it does is like it heats up that thing, and then the vapor goes to another beaker, and then
yes,
it condensates.
yes, it condensates because its boiling point is low. So obviously, it will evaporate easily and it will evaporate faster than the water. So it will evaporate here, and this is the cooling area. Okay, this is the cooling area of. So here acetone will cool down, and then your acetone will collect in this beaker in the form of this water droplets. In the
And in
form
the other beaker, they will be just left with water, right?
in this beaker only the water is left, and in this beaker your acetone is there. So that's how we are separating both the acetone and water, because here the boiling point is low. So to when we'll heat it, so this will vaporize fast, and then we can easily separate these two miscible liquids. Okay. And the advanced one is this one, the fractional distillation. This we have talked about only the distillation one. Now what is fractional distillation? What is the what is the difference between the distillation and fractional distillation? So here what happens, see, let's say this is my beaker, okay, and here is the mixture of acetone and alcohol. Acetone and ethanol also we can say. Ethanol is an alcohol only, and here acetone
Ethanol, basically alcohol, or what is it?
ethanol is a mixture of acetone and alcohol.
Oh, okay, that's
Ethanol,
fine.
yes. Let me write. See, ethanol is a mixture of both acetone and alcohol. So here, in this beaker, acetone and alcohol is present, and acetone boiling point is 56, and alcohol is 78 degrees Celsius. Okay. So here the difference between the distillation and fractional distillation is, fractional distillation is the process of separating same two or more miscible liquids, but with the difference of boiling point less than 25 Kelvin. Here in the distillation part, my boiling point is not less than 25 Kelvin, right? Huh.
Can you write the definition for distillation and fractional distillation?
What?
Ma'am, can you write the definition for distillation and fractional
This is the
distillation?
definition of distillation, process of separating two or more miscible liquids. And the definition of fractional distillation is the same, process of separating, let me write, then it will be clear for you. Process of separating two or more miscible liquids, process of separating two or more miscible liquids. But the additional point is here, with the difference of
25 Kelvin.
with difference of boiling point less than 25 Kelvin. Less than 25 Kelvin. This is the additional part, with the
But
difference
the
of,
difference of the boiling point should be less than 25 Kelvin.
and here the difference between the acetone and water is how much? If we will difference 56
Currently
minus
I'm writing.
100 minus 56 is what? 44. So it's not less than 25 Kelvin. But here, if we are different, what is 78 minus 56? Fast.
Whom you're asking?
Anybody?
Mine is 22.
Yes, it's 22. So this point is what, with the difference of boiling point less than, means 22 is less than 25, right? So this is the difference between the distillation and fractional distillation. In distillation, only here the process of separating two or more miscible liquids at like any any boiling point, but here with the difference of less than 25 Kelvin. And here one more additional thing is here. This is the this is what, anybody know what is this?
Fractionizing column.
Okay, Razi, do you know what is this?
I don't know how to read it.
No, ma'am, I have no idea.
Solution?
Yes, yes, Advika.
No, I don't know.
Ma'am, does it like filter the solution?
This is the additional part here. See, in this distillation, there is no fractionating column. But here, this part is the additional. In the distillation, only from beaker, we are directly moving to this water outlet part and then the beaker. But here, this, this beaker is attached with this thermometer cork, means this fractionating column, and then water outlet, and then this pure, means the water droplets, it's is water droplets is here. So here, if there's a mixture of acetone and alcohol, then first acetone will vaporize, because acetone boiling point is less. So acetone will move to this fractionating column, and then after that acetone will, then the same process will happen as the distillation one. This acetone will cool down in this water outlet part, the water condenser, and then the water droplets will gather here in this pure liquid Kanta component. So that's how we are separating the acetone and alcohol, the two miscible liquids. Only the difference part is the boiling point should be less than 25 Kelvin in fractional distillation, and here the boiling point can be anything, but here it should be less than 25 Kelvin. Okay, and the difference is here, one more thing is there in the fractional distillation, but in this distillation only directly from the beaker to this cooling area, and then water droplets is here in the next beaker. Okay.
Okay, ma'am.
Okay, understood, Razi, Shazan, and Advika. Advika
Yes,
is not.
ma'am.
Do you now understand what is the difference between distillation and fractional?
Yes, ma'am.
Yes, ma'am.
Okay. Only in the diagram part there is a difference, and in the definition part the difference of boiling point is less than 25 Kelvin. So what's written here, to separate a mixture of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin, fractional distillation process is used. Example, separation of different gases from air, different fractional from petroleum products, etc. Okay.
Ma'am, I know some example of mixable liquids.
What?
Ma'am, I know some examples of
Miscible
mixable
liquids?
liquids. Yes.
What, Adam? Say.
There's gasoline and diesel, milk and coffee,
Milk and coffee, yes.
and like I already said, like carbonated water and carbonated
there are a
water
lot.
and orange juice.
Huh?
Carbonated water and orange juice.
Yes, carbonated water and orange juice.
Ma'am, is water and vinegar mixable liquids?
Orange juice and carbonated water. Yes, Sarah?
Ma'am, is water and vinegar?
Water and vinegar. Razi, water and vinegar are miscible liquids or not? Water and vinegar.
Ma'am,
Shazan
I think they are.
Huh?
Ma'am, I think they are miscible liquids.
Okay. Shazan, you any idea?
Ma'am, and also like lemonade.
Water and vinegar.
Huh.
They will mix.
Ma'am, like also if you squeeze lemon juice in water, those are also.
Okay. So, yeah, what?
If you squeeze lemon in water, it will be a mixable liquids.
Shazan, what about this? Water and vinegar. Come on, tell.
I mean, he told.
What?
He told it.
Water and vinegar will mix in each other.
Sure?
Yes.
Okay,
But
Razi?
same, I think. Never
Yes,
tried.
ma'am, I also think they are miscible.
They are miscible.
Mixable.
No, they are not miscible. Water
No,
and
was it miscible or mixable?
miscible, Arham. M-I-S-S.
Okay, I was thinking it was mixable.
No, it's not mixable. It's miscible.
Okay.
M-I-S-C-I-B-L-E. This is the example of miscible. Okay?
Okay.
So now this is the assignment for you, that like water and vinegar is miscible or not, and give reason that why water and vinegar is miscible or not. Is
Ma'am,
miscible.
and also like when you make lemonade, then also like
What about oil and vinegar?
Oil and vinegar.
Oil
I have to
and
think about
vinegar.
that. I need to think about that.
Okay, take your time.
Mm-mm.
It will not mix.
Sure. This one is correct. This is miscible. Okay, but what about this oil and vinegar?
Let me think.
Huh. Arham? Okay, Shazan, it is immiscible for you. And what about
And
atom?
invisible.
Sure,
Yes, ma'am,
Anna?
immiscible. Ma'am, it is immiscible.
I'm immiscible only, ma'am. Now I'm sure.
Yes, correct. It is immiscible. Even if they mix, okay, they'll quickly separate.
Separate.
Oil and vinegar are immiscible. Water and vinegar is miscible. Very easy. Now, next part is about chromatography. See, this is chromatography. Now, what is chroma? What is chromatography? Color?
This one color.
Yes. Yes. COLO. Okay. Color. Now, see, to separate the solutes that can dissolve in the same solvent, the definition of this chromatography is to separate solute. Solute means like salt, right? To separate solute that can dissolve in the same solvent. See here now. The term chromatography is based on the Greek word chroma, means color. This technique was first used for the separation of color. This chromatography is used for the separation of color. Now, how chromatography is used for the separation of color? See, chromatography is the technique used for the separation of those solutes that dissolve in the same solvent. The same definition I wrote. The separation of different components of a mixture is dependent. See, now I'll show you this diagram, then you will easily relate. Now, let's say this is a beaker, okay, and in this beaker, water is there. Water. And we put this one paper. This is my paper. Okay, see the paper clips, and on this paper clip there is a spot of ink. And if we are putting this paper
Mom,
clip,
I've seen this example before.
oh really?
Yes, ma'am, I have seen one
So
experiment. Like
you
you put
explain
a
this
beaker
diagram.
and then you put like keep like a strip and then you put like a dot of color and then it gets up and then it spreads around.
If you put this if you put this paper clip in the water, then what will happen? The different colors will start.
Like
What will happen?
just start like onto the paper and it'll just keep on going up.
What?
Like the colors, it'll just it will go up the piece of paper.
The color will mix here, like any color. But
Mom, what was the
but
name
what is
again
the-
of this?
what?
What was the name?
What name?
Like like what is example name?
Wait, let me tell you.
Like,
See,
yeah, that
here,
chromo something. What was that?
chromatography.
Chromatography.
Okay.
Yes. See here, the color which has more solubility. Now, what is the meaning of solubility? What is the meaning of solubility? Which mixed fastly in water. Sorry, which fixed. Which mixed fastly in water is what is the definition or is the meaning of the solubility which mix fastly in water. Now, the color which has more solubility means the color which will mix fastly in water will be in the higher, like here, because that color is mixing fastly in water, and the color which is having the less solubility will be in the lower of this level. Okay, so then we'll go high, then the lesser one. So mixture of this paper clip, if you are putting a spot of ink, then if you'll put this paper clip in the water, then it's a mixture of the several colors. And if that some color is having this level, like or this or this, so this orange color will define that this orange color is more soluble. More soluble means this orange color is easily mixing with water, fastly mixing in water. That's why this orange color is there in the top level of this paper. Okay, so how will, okay, let me now show you some video, but how will I show? Okay, chromatography, then it will be easy. Chromatography videos. Yes.
Mom, I have one image I sent you.
Where image?
I sent it on WhatsApp.
Oh, you send it on WhatsApp? Okay, let's see this. See, this is the water cup. See. What was that? Why my voice? Okay, wait. Let me come online back. Why my voice is echoing? Okay. So now you understood that video. Some color was going up. That sky blue color was going up. The black color was there in the down level of this paper. Why? Because that sky blue color is more soluble in water. Because that sky color is mixing fastly in water. Okay. This is only the chromatography. Means the color which is more soluble in water, which is having the more solubility. You can see the video by your own, okay? Because if I am
Mama, I gave a picture that shows the solubility.
okay, show Arham, share your screen and show a picture or any video.
No, I actually. 1 second.
So Razi, you understood what is chromatography? Only it is based on the chroma, means color.
Mom, look, here's the image I found.
Okay, sharing.
And so, like, different colors will come to different spots.
Yes. Why red is coming at the top level? Why? Because
It has
because red is
less
more
soluble.
soluble.
What?
Okay.
It
Which
is
more soluble.
okay.
Because
And green is like less soluble than red, and blue
then
is
red and the
the
lesser
yellow
one is the yellow one. Okay.
Yes.
Solubility means which mixed fast in water. So red is mixing fast in water. That's why the level of the red is higher than the green and then the blue. And then the yellow. Okay. So everybody got it. Razi, Shazan, what is
Ma'am,
chromatography?
can you explain it again?
Arham will explain.
So what like you what happens is like you keep just wait, let me show better example. Open. So it's kind of like there is this beaker and then you put water here and then you put like ink or a dye color. So then you put a piece like and then put some piece of paper with an ink spot on it, and then what will happen after some time? This is what, and then there will be you have to then if you then what will happen is like the ink spot will start or the dye will start coming up, but it will come depending on the solubility. This is what this is. So like yellow is less soluble than least soluble, so that's why it's low. Red is most soluble, and everything comes in between.
Because red is mixing fastly in water. I know.
Yes, ma'am.
Yes. So see,
But if
Razi.
you put a different liquid, it will change.
Yes. Razi, any doubt in chromatography? In this line, any doubt? See here, the ink that we use has water because water is a solvent, है ना? As the solvent, and the dye which is there in this paper is soluble in it. So as the water rises on the filter paper, it takes along with the dye particles. Usually what will happen, a dye is a mixture of two or more colors. So if we will put that paper on the dye in the water, then what will happen, the colored component that is more soluble in water, it will rise faster, and this is the way the color gets separated. Now Razi, you understood about this chromatography? Any more doubt? Razi, are you there? Okay, Shazan, are you there?
Yes, ma'am, I'm here, ma'am.
Understood about this chromatography? Understood or not?
A little bit. Just can you explain just once again?
Arham will explain now. This is the easy. See what's happening here. Chromatography is the
Chromatography is it's like when you put a slip of paper into a beaker that has water like at the bottom, and there's an ink spot. When it reaches the ink spot, after some time it just goes higher and higher. It depends on how much solubility is there. So if there's more solubility, it'll be higher. Less solubility, it will be lower, and solubility depends on the solvent. So if you change the solvent, it will be different.
Okay, Shazan. See, if there is a ink that we use in the water as a solvent, and in that ink there's a dye in it, and what is the dye? Dye is a mixture of many colors. So what will happen if we'll put this in the water, and if that color is more soluble in water, then that color will rise faster. then the less soluble. Shazan, any more doubt? Are you paying attention?
Yes, ma'am, paying attention. Ma'am, that color will.
If that color is more soluble in water, soluble means which will mix fastly in water.
Okay.
So that color will rise faster. See,
So, ma'am, it will leave the cloth and it will mix in water.
it will mix with water. If
Okay.
this
It
green,
won't drip out. It will just.
it won't drip
come
out. It will just level wise level. It will mix it. If the green is having the more solubility, then it will be in the the higher level of the level. If orange is having the less solubility, then it will be in the lesser level, in the lower level of this paper. So in this way, all the colors get separated level wise level wise level. Okay.
Okay, ma'am.
Arham, you got na?
Yes, ma'am, I got it.
Okay, Shazan. Now, what is this? This is the separation of different gases present in air. This is the additional topic in your syllabus. Means, yeah, this is the very easy. See, in this, what's happening? This is the air in, and what air is? Okay, wait. Here, the topic is separation of different gases present in air. Now, what is the different gases present in air? In air, there is N2, O2, carbon dioxide, argon gas also. Okay, so in air there's a mixture of several gases: nitrogen, oxygen, carbon dioxide, argon.
Ma'am,
So
there is like nitrogen, oxygen, argon, carbon dioxide, neon, helium, and hydrogen, and
yes, many more.
many other.
Yes. So here what will happen? Air is sent through this path. So here this is the compressor. This is the compressor. Now what is the need of this compressor? Now compressor is here which will compress the air. Compressor will what? Compressor will compress the air, means it will decrease the temperature of air. Compressor will decrease the temperature of air. Compressor will do what? It will decrease the temperature of air. Now your air will go through this level, and this is what? This is the freezing cold water, means, and now passing the freezing water, means your air first your air is passed through this compressor. Compressor means which will decrease the temperature of your air. Now air is passing through this level, and this is what? This is the freezing part, means this will this will decrease the temperature of your air more. This part. Now your air will go like this, like this, like this. First you okay, so here from this part your air will go to the cold compressed air, means your air is fully compressed. Okay, so this is the cooling gas. This is the cooling gas part, means it will decrease the temperature of your air more than this compressor one. So this is the cold compressed air. Now here what will happen? This is the separator, means from this path your carbon dioxide will be out as a dry ice. Okay, and your nitrogen and oxygen will go from this part, and here is a expansion jet. So the nitrogen and oxygen will pass through this expansion jet. Now your nitrogen will also out.
And argon.
Huh?
And argon also.
And argon also. And here will be the liquid oxygen. Oxygen is collected in this chamber, in this beaker. So that's how the different gases it's separating. Okay, first your CO2 is out as a dry ice, then your nitrogen and oxygen. If the nitrogen and oxygen is passing through this expansion jet, then they are also out. Now at the last, the oxygen is collected in this. Okay, so this is the additional topic. This is the very complex one, very easy also. This is not there in your NCERT book. And the last is okay, yeah, this I've already discussed now. Crystallization and evaporation. Okay. This is the question. See, Razi, are you there? Razi? Okay, Razi is not there. Okay, Shazan, this is the question. Sand plus salt plus sand plus ammonium chloride, iron fillings and water. How will you separate the mixture of these? First, what we will do? First, we will do filtration. Filtration, we will separate what? Through filtration.
Sand, ammonium chloride and iron.
Then what will happen?
We can use hand picking to separate. Ma'am, we can use hand picking. So to separate iron fillings from sand and ammonium chloride.
Why we will use hand picking? Why can't we use that
Yes,
Magnet.
that also you can use. That also.
magnetic separation, right, Adam?
Yes, ma'am.
Yes, magnetic separation. After that, what we will use means this is also now you're separated. Now sand plus ammonium chloride is left.
Sun plus one.
Now what will you do? Ammonium chloride is there in one separating mixture part, in one process. Any idea?
I forgot its name.
Ammonium chloride. See, ammonium chloride. And this
Oh,
is
vaporization. For
yeah.
sublimation.
This is the sublimation part. So we will do sublimation also to separate ammonium chloride, right? You don't know about sublimation, Shazam?
Ma'am, I know, ma'am, I know.
Okay.
From water to gas, means solid to gas.
Solid to gas. So yes, very good. Now all the topics are cleared about the separating the components of a mixture.
Yes, ma'am.
Separating the components of all the processes are clear. Sublimation, chromatography, fractional distillation, crystallization, evaporation, and
Centrifugation, I don't think we have covered today.
oh yes, centrifugation is left. Yes. Let me explain that. Where is it?
Now it's already 6 o'clock, so I don't have our grammar class.
What is centrifugation? Yes. What is centrifugation?
Ma'am, it's like centrifugation, it just sounds like something is spinning.
Yes. So here, two components having difference in densities can be separated by centrifugation. This method is based on the principle that the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. A device used to separate liquids from solids by spinning is called Centrifugal machines are commonly used for this methods. The machine can be rotated either by hand, example manually or electrically. So here see what happens here is if we are rotating a stone, let's say in a circular direction, then what will happen? If that stone will, then what, see if let's say I am rotating a stone, okay, then what will happen? If stone will break, then then what will happen? Aram? It will go outside. It will not come inside. It will go outside. The centrifugal force. Okay. So it's a method of separating the substandard particle of a substance from a liquid from which the mixture is rotated at a high speed. Here what's happening? The denser the particles are forced to the bottom, and see this is the centrifugal force. This thing is rotating, right?
So if you spin a bottle of water, the water will always come back to the opposite side that you're spinning.
What are you?
Like if you're spinning a bottle of water, if you're spinning it from here, the water will always go here.
Yes, the water will always be there. And forced to the bottom and the lighter particles stay at the top. So the centrifugal is only like the centrifugal force, that the force is, the outside force is applying here. This is the easy way. The washing machines to squeeze out water from wet clothes. This is also a type of centrifugal force, that washing machine is squeezing out the water from your wet clothes. Okay, the dairies and homes to separate butter from milk means the butter is squeezing out from that cream, means the centrifugal force is also applying here. Okay.
Yes, ma'am.
Shazan, okay? So this part is done. From next class, we will learn about this. This is the last topic, the physical and the chemical changes. And one more topic is there about the saturated, unsaturated solution. That I'll